Hi, 7th grade. Welcome to lesson 6-4, make more comparative inferences about populations. By the end of the lesson, I want you to be able to say, I can compare populations using the mean, median, mode, range, interquartile range, and mean absolute deviation. Let's explore it. Jackson and his brother Levi watch Jewel Geyser erupt one afternoon. They record the time intervals between eruptions. The dot plot shows their data. Jackson estimates that the average time between eruptions is 8 minutes. Levi estimates that the average time between eruptions is 8.5 minutes. Construct an argument to support Jackson's position. Well, Jackson says that it's 8 minutes. 8 minutes looks to be the median number. We can check that by crossing one off from each side. Remember, that's how you find the median. So just checking. Yep, and 8 is the median. Okay, construct an argument to support Levi's position. Well, Levi's position is the mode. Remember, the mode is the number that appears most often. All right. How can you determine the best measure of center to describe a set of data? It depends on if there is an outlier. To be safe, the mean is always one of the best measures of data. Example 1. Quinn collects data from a random sample of 27th grade students who participate in a youth fitness program. Remember, that random sample is great. Random sample means it is representative. So write that in, representative. She compares the number of curl-ups each student completed in 30 seconds last year and this year. What can Quinn infer from her comparison of the data sets? So first, step 1, display the data sets in dot plots. So we have the curl-ups completed last year and the curl-ups completed this year. Use dot plots to compare the two data sets. So last year you can see that the mode is 24 and this year the mode is 28. Last year the range was 7 and this year the range is 5. The number of curl-ups completed this year is generally greater than last year, but based on the shape of the data, not all students made the same progress. Quinn can infer that most of her classmates were able to do more curl-ups this year. So just looking at the mode and looking at the range. Remember, the range is that spread, the variability. Try it. Quinn also collects data about push-ups. Does it appear that the students generally did more push-ups last year or this year? It appears that they did more this year. More of the data, so like I would say the data was clustered between 2 and 6 last year, and this year it's between 6 and maybe 10. So I would say this year, majority of the data increased. Okay, if you look at comparing the mode, last year the mode was 4. This year the mode is 7 and 8. Convince me, how does the range of these data sets affect the shape of the dot plots? Well, range is that variability. So if you have a wide range, the points are more spread out. If you have a small range, the points are less spread out. So it affects the spread. Example number 2. Use measures of center and variability to compare populations. Quinn computes the mean and the mean absolute deviation, MAD, for each data set. How do these measures support Quinn's inference from the data displays? Well, we already know the mean is when you add up all the numbers and divide by how many numbers there are. The mean absolute deviation is how far away the mean is from the highest and lowest. So mean absolute deviation is talking about the spread. So this is a measure of variability. If it is a low number, all the points are close together. If it is a higher number, the points are more spread out. The mean can be used to describe the data because the data sets do not have outliers. So the mean is that measure of center. The mean number of curl-ups completed this year is greater than the mean number of curl-ups completed last year. This supports Quinn's inference that the number of curl-ups has increased. The mean absolute deviation is greater for the number of curl-ups completed this year. This suggests that not all students made the same progress. Example 3. Use statistical measures to make predictions. Rafi, one of Quinn's classmates, reported the numbers of curl-ups he completed this year and last year. He did not tell Quinn which number is for which year. Based on the data that Quinn gathered, which number most likely represents the curl-ups he completed last year? Well, between 2019 and 23, and it looked like most people increased from last year to this year, you can infer that the number of least curl-ups, so that 19, is what happened last year. So based on the data that Quinn gathered, she inferred that most students could complete more curl-ups this year than last year. So Rafi most likely completed 19 curl-ups last year and 23 curl-ups this year. Peter surveyed a random sample of adults and a random sample of teenagers about the number of hours that they exercised in a typical week. He recorded the data in the table below. What comparative inference can Peter make from the data sets? Well, looking at the mean, who exercised the most? So based on this data, teenagers exercise longer for more hours. Mean absolute deviation, teenagers have a smaller variability, but this is pretty close. So I would say not to compare those two. You could say that since the mean absolute deviation is similar to both of them, it's good data to look at. It's got the same amount of spread, same amount of variability. Key concept. You can use dot plots to make informal comparative inferences about two populations. You can compare the shapes of the data displays or the measures of center and variability. So for data set A, the mean is less than data set B. You can compare the modes, you can compare the ranges, you can compare the mean absolute deviations. Remember, mean absolute deviation is a type of variability measurement. Let's say it. Oops. I can compare populations using mean, median, mode, range, interquartile range, and mean absolute deviation. Have a great day.